up and try again.
Welcome back to another segment of Learning Through Mistakes. My name is Cristian Servin, and today we're going to talk about one particular mistake or error that we usually get, usually when we try to transform one data type to another one. Primitive types. This works usually when we are dealing, for example, with doubles, and then we wanted to assign it to a whole number, an integer. So we're going to demonstrate this through a program, and we're going to use this as an excuse to show you how to generate random numbers. Random numbers play an enormous role in computer science. There's multiple applications that you can see here that they're widely used in computer science, data science, and cybersecurity. In particular, cryptography is one of the most, applications that you can use random numbers. There's two different ways that we can generate random numbers in Java. One is by using the method random, and the other one that is the object random that provides you more flexibility and more different options to generate random numbers. So let's go ahead and take a look in this video.
The very first way to do this is by using what we call math.random. As you can see here, math.random will generate a random number between 0 and 1, not inclusive. So 0 is for sure, 1 is not for sure, because 1 is not inclusive. So exclusive, it's the 1. This piece of code is very valuable, super valuable, because it generates 0 to 1. But your question is, 0 to 1 is not important, Professor. We want something more significant. And that's why we use the power of the multiplication or the product. So you know that this number for sure will give you 0 and 1. So what happens when you have a number that you multiply, for example, times something? That will amplify it. So we know this is a double. So when you multiply by a double or an integer, it will give you a double. So here what we need to do is, in case you want to generate, for example, numbers between 0 and 10, you might have to include the 10. This guy gives you from 0 to 1 and not 1 inclusive. That means that the 10 you will never be reached. If you want to include the 10, what you need to do, you need to generate multiplies times 11. That's what you need to do in order to include the 10. Now, give you an example of this. Now, since this is a double math at random, you expect a double. So here is R, which is basically this. To demonstrate this, you can generate just a loop in order to generate that part. So here I'm generating 20 random numbers. If you can see here, if you want to have a real, like a whole number for that particular value, you need to put here an int, and everything that you generate from this guy, this particular guy, what you need to do is typecast it. So if you want whole numbers, this will generate numbers between 0 and 10, inclusive the 10. Let me just try this again. I'm gonna compile my program and I'm gonna run it there. So that includes the 10. If I don't have the 11, that will not include the 10. So 11 just make sure it goes beyond. So notice that when I have a double, you have 10 point something something. Because of the int, you truncate them down. That's why you obtain the 10. So let me repeat what we just did, all right? Suppose that we want to generate 20 random numbers. Yeah, that's why I put here 20. This for loop, the only thing that is going to do is going to generate 20 times this statement, which is math at random times 11, and then put it in a variable called r and just print the variable r. I mean, I know you can simplify this big time, but I just want to do it step by step so you don't get lost. So here, what we're doing, why we're multiplying 11, is because we want to include the 10. So I'm gonna generate this random values as doubles so you can see the outcome of this. Let me just compile it real quick. And here, as you can see, there's a couple of numbers with a lot of precision that we don't need, right? I'm interested in particular to see this and this and this. There's all tens, right? what we want to do, if you're looking for whole numbers, so obviously math at random generates doubles. Here you might say we need ints, professor. I know we need ints there. The only problem that is that math at random will generate a double. And if I attempt to do this, even if I save it and I try to compile, Java will complain with the following error saying that you have an incompatible types. The incompatible types comes from the fact that you might have to lose conversions from a double to an integer. Okay, this is what's happening. You're expecting an int in the left hand side, but math at random is a double. So this operation will generate a double and will try to store it in a whole number. So Java will complain immediately because of this fact. What you can do now, you can do this what we call the typecast. So typecasting says, you know what, Java, do your math at random times 11, and when you're done, I'm gonna transform it into an int. So this is what I was paying attention into these values, yeah, because the int will basically chump all the precision. So at least we include the 10. Just check the difference. At this point, we can generate the whole number here that we're looking for, the 10. So we have 0, 1, 2, 3, maybe the 4, 5, and so on, right? All the way to 10. So I generate a couple of values here in Java using a loop just to demonstrate this part. The other part that we need to do is when we include the object random. In order to do so, we need to import a library called random. So here, instead of having the math at random, I'm gonna generate a value called random. And I don't have to do it inside of the for loop. I will do it just for consistency purposes. But if you create a random number, as you can see here, you can create a random R, or let me just put here rand equals new random. And you can use something called rand.nextInt, and you can put here the 11. We need to import the library, which is kind of like a bummer because we try to avoid to call these friends, yeah, but that is okay. I think it's more object oriented here and it has more functionalities in case later on you want to do something more specific. Randoms, you can do that thing. Let's compile and run it. So notice here that we get something similar to the previous example. This time we only have to use the random. It's very similar. The random object you can incorporate here and call next int. Incorporate the largest bound. I think they call it bound, upper bound. We basically include the exclusive part, the inclusive part that you want to do, which is 0, and exclusive that number 11. So since this is 11, that will not be included. So here we're interested in numbers between 0 and 10, and that's what we got.
So we have learned two different ways to generate a random number. One is by using the math at random, and the other one is by using the library random, which have more extensive libraries in order to generate this random number. The nice thing about math at random, which I do like because allows you to generate a random number right away. I mean, the only thing you have to do is in case you want to expand that range, you have to multiply by a larger value. That will give you more extensive range of values. And of course, if you need, for example, a whole number, you will have to use the typecasting. That's a trade-off. Random is more useful, to be honest. There's more libraries, more methods that you can use in the library random. So of course, there's always trade-offs, as you can see here. But if you want to explore a little bit more about this library, I will invite you to go to this link and take a look at that whole literature that is right there. The error that we have there about incompatible types, that happens when you're trying to fit a double into an int. Of course, we just saw a very simple problem there, but that's very common, more common than you think. When you're trying to combine primitive types, Java will complain with that particular error. That doesn't happen when it's the other way around. If you're trying to fit an integer into a double, Java is fine with that. It happens only when you have a double trying to be fit in an integer. It's because Java has a high precedence on double over an integer. Thank you so much for watching this video, and I will see you next time in another segment of learning through mistakes. See you next time.